Good day, ladies and gentlemen. This is Sarah van Geren, aka Mr. VG, and this is video 2 in the series on analytical geometry, specifically looking at gradients and lines, straight lines, the equation of straight lines. So buckle up, because this is a very, very important video, not just for this year, but actually for the 2 years coming up. When we're talking about gradients, I hope you know that the formula is y2 minus y1 over x2 minus x1, and this is equal to m. Some of you also know that it is delta y over delta x, or some of you might even recognize the formula as rise over run. They are all exactly the same formula. Now, gradients are one of the most interesting and amazing topics in mathematics because it leads to so many different things. This year specifically, we are going to look at 4 things that gradients are going to lead to. The first thing that we are going to have a look at is something called collinearity, where the gradient between A and B is equal to the gradient between B and C. Now, I'm not going to go into much detail in this video, but in the upcoming videos, every one of these things I'm mentioning in this video will be done in detail with examples. The second thing that we are going to look at when we're looking at gradients is parallel lines, where the 2 gradients are exactly equal. So 2 lines that never cross, never touch one another, no matter how far they're extended. That is happening when the 2 gradients are equal to each other. The third thing we are going to have a look at is perpendicular lines, where the product of the gradients are -1. So in other words, where they meet at a 90 degree. Again, I'm not going to look into too much detail in this video. Keep on watching. The last thing we are going to have a look at is the equation of a straight line, because a gradient is needed to determine the equation as being y equal mx plus c. But let's dig a little bit deeper into parallel lines. So when we talk about the importance of parallel lines, we have to understand that parallel lines are definitely used when talking about the opposite sides of quads. So parallelograms, rectangles, squares, rhombi, trapeziums, all of those have at least one pair of parallel lines. So therefore I can use gradients. Also, I could use them to prove quadrilateral. So they could say, prove this is a parallelogram, for instance. Or I could be asked to use parallel lines to get the equation of a straight line. But all of these things will be discussed in the upcoming videos. So just hang on, we are going to get there. Let's quickly discuss perpendicular lines. Now, perpendicular lines are fantastic because it gets us to prove, or it allows us to prove a 90 degree. Why is that important? Because I then have a right angle triangle, which leads me towards areas, trigonometry, as well as Pythagoras. Right angles are amazing. But right angles also can be used to prove rectangles and squares. Lastly, perpendicular lines are also going to be used again to determine the equation of the line. If I've got one gradient, I can get the second gradient. keep watching in the next coming videos where we're going to discuss this in a lot more details. Lastly, the fourth thing that we said was the equation of a line. When we're talking about the equation of a line, we've got to always go back to y equal mx plus c. Now, to determine the equation of a line, we use always two steps. Number one, we need the gradient, whether it be by rise over run or y2 minus y1 over x2 minus x1. Parallel lines, perpendicular lines, however we want or we're going to do it, we are going to need the gradient. Secondly, we need a set of coordinates, and that will be given or determined as part of the question. So keep watching. This is Sarel van Grenen, aka Mr. VG. Our next video is going to look at the actual practice of the different formulas. So the next video specifically, we are going to dive into the one topic we didn't really look at in this video, collinearity. So keep well. Join me for the next video. Cheers.